Alright, we are now live. Hello everyone and welcome to today's live stream, where I'll be working on some first simulation stuff, just to test it as I have been for the past while. As we can see here, with this project, I made the hair a little bit too wacky. And also there's way too much fur in this case, so this will be lagging quite a bit. But today's goal is to take this setup and apply it to a horse. So as we can see here, I have this very nice horse animation from this person right here, which I can't pronounce their name correctly, so I won't even try. But I'm very grateful that these animations are out there so that I can do some testing with them. So yeah, I'm going to put a lot of fur on this horse and then simulate it using my custom geometry node setup. It'll be a node group, not a custom build. So let's go and try that out. So the way that my fur deformation setup works is that basically you generate the fur and then you deform the fur by a base mesh, in this case the body. You probably don't need to actually look inside here because, well, the settings are in there and I haven't gone through to expose all the settings, but it's okay. And the body needs a rest position for everything to be bound to. It's still a work in progress, but it works out okay. So let's get to transferring the fur to the horse. So I've been thinking about how to do that well, and I think I came up with a solution. And that solution is just generate the fur from scratch and then just attach it with the rest position, put the deform group on it, and it should just work. Let's see how that goes. So let's go to our collection with our horse, and now let's go and add in a new curve object. So in this case, curve empty here. And you may be wondering, wait, why are you adding in a curves object and not just like a plane for geometry nodes? That's because with the way Blender works, if you want to render this kind of fur, which, oh god, okay, a little bit of lag. If you want to render fur that actually has this thickness without actually solidifying the curve, it needs to be the curves data type. So just keep that in mind whenever you're doing that. But in my case, I'm going to remove all attachment to the original mesh just because I want the object and then to handle everything with geonodes, because in my cases it's been just a wee bit more stable if I do it this way, if I plan everything from scratch. So in this case, we're going to bring our horse into here, set this to be original, because we want the horse in the rest position. Let's go and set the position and use the rest position, which is right here. Now with this horse, you may see that there's something funky going on. There's no rig and just a ton of keyframes right here. And you might be wondering why that's happening. Here, let's hide this for the time being. And that's because this horse... Oh, also let me check the audio levels. Okay, all that's working well. Okay, and that's because this is done only with shape keys, which I'm very impressed by. Well, no, that it's exported only with shape keys. So there's no rig to fiddle around with, and the rest position, I could just click add rest position, and then it'll add it. So I don't even need to add in my little node group to just store it before any deformation. So just keep that in mind while we are doing this. Okay, let's go and generate the curve. So we'll hide the original horse, and that might be a little bit of an issue. The rest position is not actually in its A pose, but this should be fine. Should be. Yeah, no, that's barely an issue. It may lead to some things being a little bit different from one side to the other, but that's okay. Alright, let's bring you over to here. Hide you, put this into here, into a nice little frame. That should be good for now. Now let's go and distribute points on faces. So in this case, we want a lot of points. And yeah, that seems to be good. Let's set it to be 1,000. That seems to be enough for now. And then we're going to go and instance curves on the points. So instance on points, we're going to put the rotation into here, and we may edit this a little bit, but we'll save that for later. And we're going to use a curve line. Now here oh, that's funny. Let's set this to be 0.1. So here we can see that these curves are just as you would expect. They're lines. But if we realize the instances, which you should do, we'll see that these now have thickness, which is nice because this is using the curves data type. So what we're going to do now is we're going to taper the lengths of the curves. I should also mention that in the viewport and in Eevee next, the curves aren't rendered properly as they are in cycles. There's some bugs around that, which maybe we'll be fixing in the future, who knows. But this kind of tapering at the end doesn't really exist. If we go and take a look at cycles, actually put some light in the scene, we'll see that these are just flat at the ends, but the rendering does not allow for that. And in this case, I want to use Eevee just because it's fast, and I have rendered tons of fur with cycles, and it takes a year and a day with the BVH, so we will not be dealing with that right now. Let's go and set the curve radius, and this will be the curve parameter, or spline parameter. Yeah, I keep getting my Blender versions mixed up. We'll use a 1- to invert this, and here we'll see that this is probably way too big if I had to guess. 1-, that should work, right? That's probably the curve rendering doing some funky stuff. But let's do this, and maybe I'll resample this to be 3 segments. Resample curve. Let's set that to be 3. Okay, there we go. Now the rendering is actually kind of working. If it were in cycles, it would render correctly, but we deal with what we got. Okay, so now we have the curves tapering off at the end. So what else could we do for the curve generation? Let's go and put this into a nice frame and use a rotation node. Let's set this to be local. So here we can make the fur so that's a little more, normal. Just rotate like that. That seems to be good to me. Let's set the radius to be even less, because I want the horse to have just a layer of fur. Now, is this biologically accurate? No. Am I going to be doing it anyway? Yes. Just because I want to test all this. So there, that's a nice even layer of fur on the horse. And it looks, fairly okay. At the ears, it's a little bit funky, but that's perfectly fine for our purposes. Now, what I'll be doing is I will be making the fur very long because I want to make this horse extremely fuzzy for the animation to just show everything. And we will get to that. And actually, I think we can add that right now. So this will be horse curve gen. And then we will go and add in the, let's see, not the surface deform. I need to remember why I named one. It is the fur guide deform. There we go. Let's see. Oh no. Oh, right, because there's no surface object yet. Let's go and get the horse and put it into here. Now let's do the horse walk into there, and we should see that now the guide curves are following along with the mesh. Now that's the vision, something that's very nice and convenient. And we can see now that there are way fewer hairs on the horse. This is because it's only showing the guides. If we uncheck that, we can see that now all the pieces of the fur are being simulated and flowing. We should see some like double back, but as we can see, it is very laggy. That's just the way that it is. Oddly enough, this is much faster than it would be with the regular deform curves by surface node, because that one has some issues. Well, actually, in 4.3, I think there were, I forget which version it was, but there was like a 10 times speed up when it came to like sampling the UVs and all that. But we'll get to that later. But we can see here that it's actually working. It's all deforming very nicely. Again, that's the vision, something nice and convenient. Let's set this to be both. Just so that, let's turn screen space down and world space up. Hopefully this doesn't ruin the compression, but I do want to show just the 3-dimensionality of the fur. There we go, we can see that that's all looking very nice. Not as much secondary action as I was hoping for. Let's see. Oh, and I do have the force fields. I was testing this a while back. But as we should see here, if I go and move this, there should be like wind forces and such acting in all of this. Let me change the distance. This is custom stuff that I made, but that's the goal here. Oh, and we can see, yep, it is affecting everything. Let's set the strength to be -30. So here we can see that, yep, the wind is definitely working in the wrong direction, but anyway. Let's go, do we change the noise to be like 10 or so? This is the semi-broken version of the force field, so maybe I'll disable them for this. Though I do want the wind. So I think I'll go and delete you, and we'll keep the wind in here just for when I want to use it. And also, let me go and turn off, or only show the guides in the viewport so that we can see what's actually going on. So here we can see the fur is, you know, working pretty well. Just do. That seems to be good. And then once again, oh, I need to set a material, which I forgot about. Let's use a set material node. And another thing that we'll have to do is store the UV map. Which actually, wait, no, it's already stored. I don't need to worry about that. Because these are generated from the horse mesh, the UV map just gets passed through because of the distribute points on faces node, which I'm very happy about. So in this case, when we do set a new material, so new, wait for EVNext to load up. EVNext took about a minute to cook when I booted up this file, which is very fun. Oh, wow. There's a material for every single... Huh. That is interesting. I wonder what program this originally came from. Let's see, are all the materials? No, it's only on there. Let's see. File, external data, clean up, purge unused data. 27. Oh, yep, that all makes sense. So now we should see. Yep, that is all reduced again. But if we go into the shader editor, let's also go and turn off only guides in viewport. And take a look at the attribute. No, actually, no, we could just use the UV map node. It should work. And if we look at this, we can see that the UV map does indeed get transferred. It looks correct, but I'm just going to double check with the actual horse model. Which, maybe, I should be able to use the same material on both, if I'm being honest. Something feels a little bit off with that. There more than one UV map? No, only one. Interesting. We'll go and test that out. But first, we're going to go and change the material to be the actual horse material. Go and just do Control-Z, Control-V. Geometry node, just go... Ooh, it's lagging again. Let's wait for... Okay, there we go. Now we can see... Oh yeah, that is extremely messed up. I wonder why. Why would the UV map be messed up even though it's inherited from the source mesh? What custom properties? No. Let me just go and store that as a new... Actually, yeah, what? We'll do some testing. So let's store this as a UV map, which is a 2D vector on the face corner domain. This will be UV2. And, oh, interesting. Very interesting. Why, yeah, why? Okay. Let's do just a little bit of debugging. Yeah, that seems to be fine. That seems to be fine. That seems to be fine. So why is it freaking out? Maybe it's because I'm... Okay. What I'm going to do is I'm going to get it from the attribute directly. So this will be UV map instead of going through this one. And that's the wrong material. Let's go to horse shape, which is the thing for there. Take a look. Wait, why does that one work, but that one's messed up? Just another reason to do absolutely everything with geometry nodes attributes rather than relying on that kind of stuff. Now it is a testament to just how reliable geometry nodes has been for me. See, so we have that, and we can see that it's working okay. Also looks like there may be subsurface scattering already. No, nothing. It looks very soft. I like it. In terms of specular, we can chop that out as well. So, do we keep the roughness? Nah, it'll be fine. We just want the color. Just eliminate everything else. And all that seems to be fine. Let me just go and make sure that all the materials are, like the roughness and such is working as intended. Wow, that is very glossy. Let's bring that to something that's a little more reasonable. So blurry. God. What do I need to change in here to make it not super blurry? Spatial reuse. I mean, that helps a lot. Look at that, the difference. Wow. The noise isn't too bad after like 3 or 4 samples. Okay, so let's go and put the horse texture back on there, and it looks a bit uncanny. Especially because I think there may be some fur inside that, yep, there's fur inside the mouth. Now I could add in a vertex group to go and eliminate everything on the inside of the mouth. But I'll just wait on that, because that's not too important at the moment. So once again, we're using just the attribute node to get that data because apparently it is more reliable. Let's go and set the guide curve count to be around 8 or so. And we can see right now the wind is too powerful. Let's see. Imagine rewriting the engine for years just for it to be noisier than Cycles. I wouldn't say noisier than Cycles. Is definitely a lot noisier and blurrier than EV Legacy, and I've talked about that quite a bit. But it's still better than Cycles for real-time stuff. And EV Next, well, it does have issues. It does have quite a few benefits that I've been liking. And the main thing that they're kind of preparing for is for Vulkan support, which I hear when that comes around, it will be much faster. Which I'm looking forward to. I hope that becomes a thing. But it has, yeah, it's taken a while. EV, for those of you who don't know, EV Next planned to come out in like 2022, 2023? No, 2022, and then it got delayed for 2 years. So it's had a time. Let me turn off motion blur, because that's making this a lot worse. So, you may be wondering, how do we speed this up for production environments? Well, first of all, let's go and use the bake node to bake this, and we can see that that improves speed by quite a bit. But usually, you'll only have the guides in the viewport, and then you'll go and just, wow, that looks very sad, very sad. You would only have the guides in the viewport. You would go and make sure that part of the simulation is okay, and then when you render it out, I'll render it at full res, because when you're rendering, especially like in Cycles, it'll be taking hours anyway. A little bit of fur calculation is, you know, not exactly horrific. There we go. I do like the black fur, because it shows the shine very nicely. But let's try other colors, some unnatural colors like red. Now that just looks like it's made out of plastic. What about a Christmas tree horse? That would be pretty interesting. And that doesn't look all too great. But we can go and use some other stuff to make this look better. If we look at the hair, or is it curves info? There we go. We can check the is strand, which that one, even though everything appears white, that's very useful for like differentiating the horse mesh from the curves, which is good. Let's see. Unfortunately, I cannot read the language that's being typed in the chats. Very sorry if I skip over that. Unfortunately, I do not have Google Translate at the ready. But the is intercept, sorry, can be used with the hue, saturation, and value node. So in this case, we're going to offset the hue of the beginning of the curve. So we'll use a 1- to invert this, put it into there. So here we can have this in like the green territory, and then we can lower this and make it look like that. This look like the wind is causing some issues, so maybe I'll just disable the wind. But as we can see here, we can just go and edit this so that it looks good. Like, ooh, yes, I like those hues. Whenever you go down in value, you just shift the hue and then it looks amazing. So, let's see. Is that your custom nodes? We're currently working on fur in Blender, and it's sad to know there's no fur simulation by default. They added the fur, but the simulation is not. This is using a node group, but no custom nodes. This will work in any 4.3 thing that you bring into Blender. My curve deformation setup, so no simulation, but deformation, is currently up on Gumroad. It forms like meshes by a surface, curves by a surface, instances by a surface, so I would recommend getting that. But for simulations, especially with guides, it's rather complicated, and my proprietary system is not out yet because it's just, I haven't put enough time into it. But if there is demand, then I probably will work on it more and potentially release it, but it probably would be paid. Because, yeah, it takes time. Let's see, let's use the randomness to offset the colors by a bit more. So, that looks beautiful. Look at those hues. I could offset it even more. Look at that. I do like those colors. Let's go and offset the hues by a bit more. In this case, it is a little... Let's use the power node to take the random. So here we can see there's that, and then we increase the power to change the fall off of this. Now, powers can be rather expensive just in terms of computing. That's what I've heard from friends that know way more about this than I do. But if we're using like Eevee Next, that probably won't be an issue. But yeah, it's not an expensive shader in this case. Maybe if you were doing like a ton of complicated shader stuff, then if you had a ton of power nodes, it would be expensive. But in this case, I don't think it'll even add more than 1/10 of a second. Probably nothing. See, a little bit of that's okay. Now I want to try other colors. That looks interesting. Interesting. Let's go with a light kind of tannish color, and then we'll offset the hue to make it more into the reds. And we'll set you to be 0.5 because we'll edit a bit of this. We're just experimenting. That looks pretty good. Though I think we can still change the fall. So we'll use another power node, and we'll put this over to here. And we'll set this to be 0.25. Not really feeling that. Now, we could just use a float curve, which I wonder if the float curve is more or less expensive than the fractional powers. We can change the curve, and not bad, not bad. I also should mention that I'm not using the standard output, which is the actual colors. I'm using Filmic because it's more, you know, realistic. And I've heard that Filmic, or maybe I should use AGX. I've heard that AGX is even better than Aces, but in the professional sphere, Aces is still used all the time. It's the industry standard, and for good reasons as far as I know. Let's go and set this to be... Yeah, that's the most red I can make it. And that... No, that doesn't look good. The hue shifts. I do enjoy the hue shifts. It makes everything look better. Let's set that to be 0.5. Not really feeling that. Set that to be... I don't know. I'm not really feeling the randomness. Not really. Maybe a little bit to add in a little bit of variation, but it just feels too random. Oh, though, I completely forgot, with this setup, I have the guide ID I can use with a white noise texture. Is there float point? Yep. We need to snap this by a very small increment because integer conversion to shaders is still a little bit funny. We'll read the chat in a quick second. There we go. With this, it now snaps it so that we can get the white noise. It's because, yeah, the integer conversion in shaders is still kind of funny. And I'm not entirely sure why. But here, we can go and offset the different clumps by random value, which this is using, again, the guide ID for that. So that's cool. Let's go and put this into here and see what we can do. This will probably look bad Like maybe in this case I would only offset the ends, not the beginnings. Yeah, interesting. But I think we'll forego that. Let's go and look at some actual lighting, and yeah, that's not too bad. We could add in some subsurface scattering. It looks like it's made out of hay, which I guess is fine because hay is for horses. It's probably the worst reference slash joke that I've ever made. So cheesy. A little bit of subsurface scattering works, but I think that's fine. But we're getting away from the main goal, which is to work on the actual, you know, special stuff, which is the fur deformation, rather than... But it does look amazing, like, look at that. Rather than the look of the fur. I'm just getting lost in the beauty of it. Do I have the collisions in this? Yes, I do. And that's colliding in the deformer collection. Oh, right. Yeah, I need to expose that. So I'm going to expose that. So let's make a group input. That's for the collision. And we'll make this collection 5. So that is our collider. So now the fur will collide with the horse model, though it doesn't appear to be happening. No, it is kind of. Kind of. Maybe I should disable it. Collisions are the most annoying thing that you can do in Blender. In geometry nodes, I should say. So do I have the... Okay, I did not put in the failsafe. So in the domain size, if there are no instances, it'll just completely skip over the collision step. In this case, we will use a switch node. If the instance count is 1 or more, it will do the collision, but in this case, it will just whoop, skip right over it, as it should. There we go. So now this should be a bit faster, because there are no collisions going on whatsoever. It's not that bad. Like, again, because we have the force fields, in this case, the wind going on, that's causing that to happen. And I could remove the force fields, or say when no force fields are there, just say, just skip it, because that could make it a bit more expensive. But I think most of the delays that we're having is just with the straight up deformation, not simulation. Because if we turn this off, we can see that it's running in real time. Now again, there are only a few thousand, but that's usually what you want. So let's go and take a look at that. That's looking very nice. Let's go and do just a little bit of lighting. So we'll put a sunlight into here, and I could go and put an HDRI, but even that's looking quite nice, if I do say so myself. Directional lights. Now, you want tons of ribbon lights if you want something to look good. But I think in this case, because, you know, it's fairly directional already, that looks very nice. And dare I say, I think this looks better in Eevee Next than Eevee Legacy. I'm pretty sure. Again, even though I do have my complaints with Eevee Next, it does lead to better results in some cases. As long as you have the denoise. And now let's take a look. Oh, actually, with the denoising on, it doesn't look half bad. Maybe it was when there wasn't a direct source, or maybe the denoising works on like the world a lot more than sunlight. But yeah, like the ambient occlusion and stuff like that. And the global illumination, we can turn that on or off, but let's keep that at 0.5. Let's see. Yeah, that looks good to me. Nice. We can add in a nice plane for the ground. And set the scale to be 10 now. Let's keep it in the ethereal void. What else can I do? Because this, you know, if I were to render this, I think it would be fine. Let's move the camera so it's not facing the horse's backside. That's pretty good. And then I could just repeat the animation so that it gets a few cycles in. And yeah, let's move it like there. That's one benefit of the shape keys. You just copy that, no rig to worry about. Have you ever tried to experiment with Unreal Engine? You know, it's free and accessible after all. For some work that I do, it is done in Unreal Engine. Now, you may think, wow, you must really like Unreal Engine. There are aspects that I like and there's aspects I don't like. The main aspect that I dislike is it is so heavy and bloated. But you can do a lot with it. But personally, I prefer Unity just because it's light and fast and it feels better. Just feels better. Even though, you know, it doesn't have all the fancy bells and whistles. If you're making like a AAA game, use Unreal Engine because, you know, it has all the fancy stuff for that. But if you're working on personal stuff, Unity. You can do a lot of shader stuff in Unity, which some of my friends are doing amazing stuff with that. Like Radiance Cascades, which you probably could do in Unreal, but, you know, I don't know if it would be more complicated or not. But yes, here we have all this. And if you're wondering why I don't use real-time applications rather than, you know, and why I'm using Blender to do stuff that may be easier to do in real-time applications, basically for the big projects I've done, they've all been in Blender. Rendered in Blender and all that good stuff, so it's a guarantee that I will be using Blender. So I want to make my time inside Blender better if it's a guarantee that I'll be using it. See, we're at 30 minutes. Yeah, we can end the stream soon. I'm liking these shorter streams rather than doing like an hour or two. Let's see. Awesome as always. I would love to see you develop some sort of FEM solver in geometry nodes for soft body simulations with constraints. I know people have done soft body simulation inside of geometry nodes before, but I would recommend waiting until the devs implement it. Because right now, some of the devs are working, one of the devs is working on hair simulation, which you may be wondering, you may think, wait, if you made hair simulation, why are they working on it? It's because the hair simulation that you're seeing right here is awful. Collisions are mediocre, no friction. And the simulation in this case, I don't think is using delta, actually no, this is using delta time. But it's not great. It's not great. I added some better lighting with this. What would be like really nice lighting with all this? I could try a translucency shader, but I don't think that would do too much more to benefit this. Let's set this to be a very powerful light. Nah, with the fire, I think it's just too noisy. Too bright and too noisy. So we're building the lighting around Eevee next. Let's see. If you used a brush to control the direction, will it retain it during the simulation? It should. Because in this case, if I were to go and change the generation, so let's go and trash the bake for the generation and then flip these. Let's actually go and turn this off. And make it so that all the fur is facing upwards instead of downwards. And then bake it so that we just have that stored and then enable the simulation again. We can see that it's mostly following that. And that is a very interesting look. But yes, it does follow what you assign for it. Which I think I still need to edit that a bit. But yeah, for all the things that I've tried it on, it does work pretty well. Because with the guides, and I should explain a little bit of this. So with the setup, let me go and delete the old sim. Wow. It looks simple, but there is a lot going on here. I just make it into node groups because it makes it very easy to understand what's going on. You make the guides, you split up the main curves into the main and the guides. So the guides are just what you see right here, just these ones. These go, get deformed, and then get simulated, and they just do their job. And then the main groom gets deformed as well. But then the guide offsets get applied, so the deformation from what's usual. So it's like, oh, the straight surface deform, subtract that by the simulation offset, and then you get that, and then you apply that offset to all of the curves. Now, because we do not have lists in geometry nodes yet, I had to use a slow method. In this case... Oh, wait a second. This is using the fast method. I forgot. This is using no guide interpolation, and I did not even notice. So in this case, it's just sampling the guide curve and then applying the offset, which is fast. But if you want to interpolate more neighbors, you need to use this setup, which is very slow because it generates... We turn the curves to points and then we generate curves again so that the attributes get distributed. It's a hack, but it does what it's supposed to. It interpolates the guide offset so that then it could be sampled, but in this case there's no interpolation. So it is what it is. Let's go and turn the fur back on. It's looking incredible, but what else can I do to make this better? Like if we go and make it more glossy, biggest fan of that. Like maybe if there's a little bit of sheen on it, then that, oh wait, that looks a bit better. What if I use some Fresnel? Oh, does this have this surface normal stored? Because maybe I should store that. Normal. Does it have that? No, not, why did I capitalize that? What about the guide? Does this store, what does this store? Because that's one thing that I haven't added in the curve deformation setup, which is transferring the surface normal to the curves, which would be better. Let's get the Fresnel. And this is the tangent normal, which... Yeah, well, no, it looks like it's almost working. I haven't played around with this all too much. But if we use the regular normal, this is the Fresnel per curve, which is, you know, less than ideal. If we want to actually store... yeah, how would we do that correctly? How would we do that right? Like in the setup, if I wanted to do that correctly, I would have to go into the deformer and actually transfer the normal, which, oh wait, no, I could do that very simply. Oh yeah, no, I could do that very simply. So in this case, there will be, I am editing the deformer just because to save on memory, it doesn't actually store all the attributes permanently. It just uses them and then ditches them. If we set this to be spline and make this a vector, 3D vector, that should work. So I just need to sample, or I could do the rotation, but no, we can't transfer the rotation into there. So I'm going to put you into there and label this DN for deform normal. Now this will make this a bit slower unless, let's see if this works. This here. We do that. Does that lower it? No, that seems to be the same. What happens here? Actually, it's the same either way. I thought it would have been... Oh no, it is slower. But, it's fine. Let's go into the shader editor again and take a look at that attributes. So let's do DN for deform normal, and we should see, wow, that's looking very nice. It's giving us the normal from the surface and then applying it to the curves. So now if we put that into the Fresnel node, we can see that's giving us a very nice look. So I probably should store that with the deformers, but it might not be a good idea, if I'm being honest. Maybe I could make it optional. Just have a panel where it outputs all the data. No, it's still, if I use a capture attribute node. Yeah, I'm still not sure if that's a good idea. Maybe it is. Maybe. And if you're wondering why I'm not using a 4x4 matrix for the deformation, that's because I made this so that it could possibly be backported to 3.6 if I need to. But also, 4x4 matrices are more expensive and they have some interpolation issues, I've found, so yeah. Or that might have been because the smoothing the UV tangents was a pain, but... Oh, I should mention that apparently there is a UV tangent node being worked on. So, and it should be faster than our current node group setup. So with this one, for those of you who don't know, this gives us the UV tangents of the horse so that we can orient the fur properly when we're deforming and all that good stuff. And then this part right here is to smoothen out the normals. So in this case, it's just accumulating the normals by the vertex ID hashed, and then, you know, just averaging it based off that, and then normalizing it. So as we can see here, we have the flat tangent and then the smoothed tangent. So in the future, there will be a node for that, and even if it outputs the flat tangent, I can just still use this node group to smoothen it out. So that's pretty good. Pretty good. Let's go back to the shader editor. So what should I do? Maybe we can add in some stylization to this. So let's use the layer weight node instead, because this can give us a more linear gradient. It's not entirely linear, which maybe I could use a dot product to make it more linear, but I don't want to use the vector transform node with, I forgot how to set that up to actually make a Grinnell-like node setup. So I'll just use the actual node setup for that. We'll put you into here, move you up to here, delete you, take a look at you, and now we can see when we offset this, there is a nice hue shift at the end. Now we don't want it to be radioactive pink, we want it to be maybe just a bit more subtle to give the impression that like the fur is lighter. Or I could make it so that it's more translucent at the edges, because that kind of makes sense. Because we're using a real-time engine, we have to go and fake a ton of stuff. So let's use a translucent node. So if we take a look at, whoa. That is very distinct. But what does this look like in cycles? Wow, that is a lot. Let's actually check the hair, principled hair node. Take a look at that. Yeah, a bit much. Check that. Looks like hair to me. You can see there's a thing for, I forgot which mode had it, but there you can like determine the melanin in the hair. I thought there was a slider for that, but maybe I'm misremembering from like a long time ago. Oh, there we are. Yep, I remembered that. It's been a while since I've used the actual principled hair node. But yes, it looks beautiful. And we can go and tone that up or down. So we can make a blonde horse. I mean, well, yeah, blonde horses do kind of exist in real life. I'm not exactly a horse expert, but interesting to see how orange it gets by the density. And then the roughness, we can make it that, and make it rougher. Yeah, but let's go and stick with the real-time version because we can dial it in to make it look good. Because physical accuracy, well, it can look good. You know, sometimes you just want to make it look like what you have in your head. So again, we could make it look like that, which is, you know, all right, not too great. Let's set it to be 0.5. We could make it more saturated, which looks worse. I'll keep that in my back pocket. But I think for now, having it just like this is okay. Look at that. And also, just for fun, I'll wrap up the stream soon because we're at 43 minutes. But I'm going to make it so that the hair is significantly longer. This is going to look terrible, but really funny. Here we go. And it's probably ruining the stream compression, so let me change it to be 0.5 and rebake it. Yeah, but now it doesn't even look like a horse anymore. Let me set it to 0.1 and take a look at it. Bake once more. So here we can see that the collisions are having a field day. In this case, I would turn like the, not pinning, but the stiffness up so that it would try to retain its shape more. But let's go and again, bake it once more. I think this is a good length. It looks good. That'll be a nice little render and we can send it out. But yeah, this is just a little demonstration of the setup. It does need a bit more work and more options, but I think it's pretty good. What else? What else? No, I think it's all good for now. It's showing the dynamics very well. And there was also the lion that I can also add this to. Now, for some reason, the lion is a bit larger than the horse. Or wait, that is a lion. Yep. Oh, that's some interesting glitching going on right there. This means that the normals, I think this only happens when the normals are like severely inverted. Let's check the shader. Oh, yeah, there's a normal map. Oh wait, the other one didn't really have a normal map, did it? And then if we disable this, it just adds in a bit more definition, which we don't need that. So we can eliminate you and you. Specular, we don't need the alpha. And only use the color, which why is the color not going through? Well, let's just add in a new principled node and then call it from there. There we go, that's a bit better. So now, delete you, delete you, delete you. No, I'd probably, well, actually, let me go and test the normal again. Let's put you right over there, put you into there. We should see that this is, yep, that's working. So I could keep that. No, that's the roughness. No, we don't need to keep that. Or that, or that. Maybe you, but, and not really feeling it. So I could add that to there, but I'll save that for another time. We got what we want, which is a nice demonstration of the fur walking around. So yeah, that's pretty nice. Alright, and that is everything. Thank you all for watching. I hope you all enjoyed. If you have any questions, please ask them now as I am reviewing the chat. Let's see. Okay. So will you be working on upgrading such as simulation? Yeah, maybe. It all depends on when hair simulation is coming to Blender, because maybe it'll be in 4.5, I don't know. But if I had to bet, I would say 4.6. So maybe I'll release this before then, just so that people have an option. Because, you know, the best tool is the one that exists right now, not the one that will exist a year in the future. Because, you know, you can't really access that. The main problem that I saw with Blender, there can be an issue with hairs that go inside the mesh. Yes. Yep. That is the #1 problem. Is that collisions are just the worst in geometry nodes, but maybe they'll be fixed in the future. Because right now there's no inbuilt system to detect collisions, which means we have to build it ourselves, which is very slow with nodes. And I have not found a good solution that deals with friction 100% perfectly, or like bouncing and all that perfectly. I just haven't found that. Then also with like curve length stiffness, that's also very slow with geometry nodes because you have to use the repeat zone, and the repeat zone plus the evaluate and index zone just really don't mesh well. They get very slow very fast. So in this case, I'm just using the accumulate field node to fake the the length constraint. I mean, it does work, but it's not super accurate. Yeah, but oh wait, let me read all this in order. In Houdini, we can use a VDB to solve this issue. Yeah. Well, even though VDBs can be a bit tricky. Though, I can see where you're going with that. Maybe I could try. No, it feels like that would be super expensive as well. Let's see. Oh, with the Unreal comment, yeah, but Unreal doesn't struggle with complex scenes where Blender slows down to a crawl. Yeah, I mean, Unreal is made to be optimized in that case. It has auto-generated LODs and stuff like that, where Blender doesn't have that. With Blender, the intention is that you do the optimizing yourself. So you hide the stuff that you don't need for animating, and then when the fancy render time comes around, you do the stuff. Yeah, Unreal does have its place. Amazing stuff has been made with it, but for my personal tastes, I like programs that are light, and Unreal Engine is not. Again, you can do incredible things with it, but just my personal preference is not Unreal. Let's see. Is it also possible to make advect curves as in Houdini? Such a nice tool, I'd love to see this in Blender. I'm not familiar with that one, but I could look into it. Most likely, yes. I mean, well, we can recreate more effects than you would expect inside of geometry nodes. Which every time there's a new update, I'm like, okay, what can we remake from Houdini that's what effects can we remake in geometry nodes from Houdini? Wait, I completely butchered that sentence, sorry. I was thinking about something else. Yeah, what can we recreate in geometry nodes that originally was from Houdini? Now again, Houdini is still #1 and always will be when it comes to procedural stuff. They have amazing solvers, GPU acceleration in some cases, amazing things can be done. But there are some reasons why you wouldn't want to use Houdini. If, again, like in my case, I don't like dealing with subscriptions, and Houdini can be, I think it's okay on the price range. But in my case, I use Houdini if I'm getting paid to use Houdini. Which, in this case, you know, not. Let's see. Alright, I think that will be everything. But yes, I do love Houdini. It's incredible, but, you know, on the smaller scale stuff, geometry nodes is good. Alright, I'll wrap up the stream here. Thank you all for watching. I hope you all enjoyed this little peek into this. On previous live streams, I've gone over how the fur deformation setup works in depth. Sorry, I'm thinking about some improvements I can do to this as I'm doing this live. I really should stop doing that. But yeah, I did go over this in depth and how it all works, but there's so much that I need to change to make it actually solid. With all that, particularly, again, in the simulation, like, this part works perfectly fine. Like, I'm very happy with this. Like, the only possible thing I could do is, again, storing the attributes, but that's unnecessary in 90% of the cases. Even though, like, if you want to have the normals to do, like, fake collisions where the curves can't go below, they're, like, can't go below the normal. How do I explain this well? If the curve remembers the normal of the surface, which is not exactly free, but very inexpensive, that could be like a simulated collision step. So when the curve moves, it won't go below that kind of normal plane based on the root of the curve. So that could be an option for fixing that, but wouldn't be entirely accurate, so it is what it is. But yeah. Simulations. Blender is still getting up to speed with all that. We even need... oh, this was the old constraint part. But yeah, you gotta build it yourself, and what you do build, it's just not fast enough to be practical in quite a few situations. Just because with the way the repeat zone works, it duplicates the nodes, which means that there can be an exponential speed increase with like the evaluate and index zone. So that makes it, you basically just can't use it for like 100 iterations or something like that. Well, yeah, it's somewhat annoying, but internal nodes would solve that. So I'm looking forward to that. Alright, enough delaying. Thank you all for watching. I hope you all enjoyed, and I will see you all next time. Have a good one.